All right. We need to do the product of f and g. So the product of f of x and g of x. Here's my function f of x. So I'm going to have the square root of x plus 5 times my function g of x, which happens to be the exact same. Square root of x plus 5. What happens when I multiply those two together? I'm sorry, one more time. Our square roots are going to cancel, absolutely. Because I have f of g of x equals the square root of x plus 5 multiplied by itself. So the squared and the square root are going to cancel each other. And so that means f of g of x is just what? X plus 5. We're also supposed to state the domain here. And we mentioned yesterday, we didn't have a lot of opportunity to practice with this yesterday, but when we do operations with functions, they inherit the domains of the original functions. They bring them along with. If all you were looking at was our final simplified expression, x plus 5, you would say the domain is what? Negative infinity to positive infinity. Is that the domain of f of x? What is the domain of f of x? Negative 5 to infinity, because it has to be greater than or equal to 0. Same thing over here with g of x. Since it's the exact same function, it also has a domain of negative 5 to infinity. This resulting function, the product of f and g, brings the domains of the parent with it. Even though if I were to just look at this, I would say my domain is all real numbers. It's not all real numbers, because the parents or the original functions had restrictions on them. So that has to come along too. My domain here is negative 5 to infinity. Brings along the restrictions of the original two functions. It means you have to be very careful when asking for the domain, or when you're being asked for the domain, that you're not just looking at the final result. You're not just looking at the final sum or difference or product or quotient. You've got to come back and look at the original functions. So far, so good?
What if they have different restrictions?
If they had different restrictions, then our resulting one would have to take the most restrictive view. So for example, if f of x was a function such that its domain was 3 to infinity, and this was negative 5 to infinity, this would govern my restrictions here, because that would be more restrictive. Yeah, we did get kind of lucky here on this one that they both had the same domain. All right. Let's look at another example here. We are going to do both a sum and a quotient. Let's do our sum first. F plus g of x well, my function f of x is this one right here. So 2x over x minus 4. And we are going to add that to our function g of x, which is x over x plus 5. If I'm going to add these two together, what do I need? Yes, we're going to need a common denominator. So the first expression, my f of x, I have to multiply top and bottom by x plus 5. And my second expression, g of x, we need to multiply top and bottom by x minus 4. All right, so I'm just going to write that out. 2x times x plus 5 plus x times x minus 4, all over my common denominator of x minus 4x plus 5. All right, let's clean up that numerator a little bit. We're going to distribute the 2x. And we're going to distribute the x back here. So I have 2x squared plus 10x plus x squared minus 4x over my denominator. Can we simplify that numerator at all? Yes. How will that numerator simplify? 3x squared plus 6x. Over our common denominator. Before I can call this fully simplified, because it is a fraction, I have to make sure that it's fully reduced. How can I verify that it is fully reduced? See if anything can cancel out, which means I have to have everything in its factored form so that I can verify whether or not any of these pieces can cancel. My denominator is already in factored form, so I'm going to leave that alone. Can the numerator factor at all? Yes, I can factor out a 3x. And what would I have remaining if I factor out a 3x? X plus 2. Once I have it in that factored form, now I know for sure that nothing will actually further simplify. Nothing is going to cancel. So that would be my sum right there. And then it said for each of these, we are supposed to state the domain. If I'm going to write the domain after I have done a sum, just like we saw in the previous problem with the product, I have to make sure that it brings along any restrictions from those original functions. Do we have any domain restrictions on f of x? Yes. X cannot be equal to what?
4.
X cannot be equal to 4. Are there any domain restrictions with g of x?
-5.
Yes. x cannot be equal to negative 5. So we're going to take both of those domain restrictions into account here. X cannot be equal to 4. X cannot be equal to negative 5. As far as we know, can x be every other value?
Yeah.
Yes, as long as it's not one of those two. So we're going to write this using intervals. Negative infinity up to what? Negative 5, parenthesis, union, negative 5 to 4, parenthesis, union, 4 to infinity, yes. So we took the domain restrictions of each of these original functions into account when we wrote the domain for our sum. All right, let's do our quotient. So f over g of x. This is going to look like a hot mess to start off with because f of x is 2x over x minus 4. G of x is x over x plus 5. Fractions inside of fractions. How do we handle this?
Flip it.
Yes. We're going to multiply by the reciprocal of the denominator. So that means I'm going to rewrite that numerator just the same. That's going to stay 2x over x minus 4. We are going to multiply by the reciprocal here, so x plus 5 over x. And then we multiply straight across. I'm going to leave this in factored form, at least for right now, to make sure that we get this reduced as we need to. Will any of those pieces cancel? The x's here. The 2 won't cancel, but the x's will. Yes. So my quotient of f and g you can choose to leave that undistributed. So you could write it as 2 times x plus 5 over x minus 4. Or you could distribute that to be 2x plus 10 over x minus 4. I will leave that up to you. I would count either one of those as fully correct. Either way of writing it, I see that it is fully reduced. We still need to do what? We still need to do the domain. All right, so it's definitely going to inherit the domains from the parents, but because it's a quotient, what else do we have to watch out for? What can't be equal to 0? The denominator. So looking right down here, g of x cannot equal 0. What values would make g of x equal to 0?
4.
Remember, g of x is x over x plus 5.
0, 5.
So negative 5 would make the denominator of this 0. What would make the function equal to 0?
0.
0. X, my numerator can't be 0. If x was negative 5, it would be undefined just inside itself. X cannot be equal to 0. So how many restrictions do we have on this domain here? 3. X cannot be equal to 0. X cannot be equal to 4. And x cannot be equal to negative 5. So I have to take all of that into account when writing this domain. How many intervals are we going to have? 4 intervals. So negative infinity to negative 5, parenthesis union, negative 5 to 0, parenthesis union, 0 to 4, parenthesis union, and 4 to infinity. Yes. What would that look like? So this quotient of functions, if I were to graph 2x plus 10 over x minus 4, it's going to be a rational function. So it would have this basic appearance to it. And it would either have asymptotes or wholes at those 3 listed places, at 0, 4, and negative 5. It would have a vertical asymptote at x equals 4. For the other pieces, I would have to substitute in to find out whether it's actually a whole or an asymptote, just off the top of my head. So, does that help? All right. Let's do one more that's just like this, only let's focus just on the quotient. We'll just do a quotient and find the domain. So f over g of x. Kind of gross again, because once again I've got 2 rational functions. So here's f of x, x plus 6 over x squared minus 36. And then down in the denominator, we're going to put our function g of x. So 3 minus x over x squared minus 2x minus 24. What do we need to do so that we can actually simplify and evaluate this? We're going to need to factor. What else do I need to do so that I don't have fractions on top of fractions and more fractions? Multiply by the reciprocal. So let's do those 2 things at the same time. We'll factor and multiply by the reciprocal. All right. So the numerator stays the same, x plus 6 over, how will that denominator factor? Yes. X plus 6, x minus 6. We have a difference of 2 squares. Multiply by the reciprocal here, so my denominator is 3 minus x. How will this factor? Yes, x minus 6, x plus 4. Do we have any pieces that will cancel? X minus 6 between this numerator and that denominator, and the x plus 6's. So I am left with x plus 4 over 3 minus x. All right, so f over g of x is x plus 4 over 3 minus x. So again, we end up with a rational function from doing this. And we need the domain of this guy. So there are several things that we need to pay attention to Let's go back and talk about the domains of those two original functions. Are there any restrictions on f of x? Yes, x cannot be equal to positive or negative 6, because that would make f of x undefined. What about domain restrictions on g of x? What can x not be equal to, or else g of x is undefined? I heard 6 and negative 4. Remember, when we factored that, we got x minus 6, x plus 4 when we factored this piece right here. So the values of x that would make that denominator 0 would be positive 6 or negative 4. Because we're doing a quotient, do we have to watch out for anything else? Yes. G of x is not allowed to be equal to 0 because it is a quotient. So that means 3 minus x over x squared minus 2x minus 24 cannot be equal to 0. We already established that x can't be 6 or negative 4 because that would make it undefined. What value of x would make this function 0? 3. So x also cannot be equal to 3. We got a lot of stuff that we're trying to hold in our heads here. All right, so I'm going to make myself a little note. X cannot be equal to positive or negative 6, negative 4, or 3. I've got 4 different values that x cannot be equal to. How many intervals do I need to write then? 5 intervals. All right, here we go. Negative infinity to negative 6. Union negative 6 to negative 4. Union negative 4 to 3. Union 3 to 6. Union 6 to infinity. That is a lot of intervals. If you get lucky and it doesn't say anything about having to write it in interval notation, I want to show you how you could also write this domain if you're not required to use interval notation. You don't have to use interval notation. We could say our domain is all real numbers except these 4 values. So you could put all real numbers minus, that's not a dash, that's an actual minus, and then inside curly brackets, I would just list out the values that x cannot be. Negative 6, negative 4, 3, and 6. So that is another way to write that same idea. I want to make sure that you guys are exposed to both ways of doing it because different textbooks, different professors, different classes might use different notations. I want you to be able to know both of those so that nothing takes you by surprise. All right. What about if I want to do an operation on 2 functions and then I want to evaluate it for a value of x? So for example, if I wanted the difference of f and g evaluated at x is 2. So the first thing we're going to do is find the difference. So we're going to find f minus g of x. And then we will substitute 2 in for x. Of course, 2 coming from this right here. All right, so let's find our difference first. F minus g of x so I would have negative x squared coming from right here minus, and because g of x has more than one term, I've got to make sure to put this inside parentheses, 2x minus 1. Distribute my negative. I have negative x squared minus 2x minus 1. Are there any restrictions on the domain of f of x? No. The domain of f of x is all real numbers. What about g of x? Are there any restrictions on that domain? No. So I can substitute 2 in. There's no problem. I'm not going to be outside of the domain of any of the original functions. So now we're going to substitute 2 in the place of the x's. So I have negative 2 squared minus 2 times 2. Oh, I drew my distribution, but I didn't actually make that a plus. My apologies. I distributed the negative to the negative 1, but then I still wrote down minus 1. I am so sorry. So then I have a plus 1 here. So far, so good? So I have negative 4 minus 4 plus 1. How will that simplify? Negative 7. Same thing, but with a product this time. We're going to do f times g of x. So just like with the other one, first I'm going to find my product. Then we're going to sub 2 in for x. All right, so first step. F of x is negative x squared. And I'm going to multiply that to 2x minus 1. So I distribute. I get negative 2x cubed plus x squared. And now I can substitute 2 in the place of x. So I have negative 2 times 8 plus 4. So negative 16 plus 4, which simplifies to be negative 12. Do we have any questions about this? We don't need to define the domain on these because they're asking us to evaluate it. But one thing that you do have to watch out for, I'm glad you brought that up, you have to make sure that whatever they're asking you to substitute in is not outside of the domain. So that's why on all those previous problems we had to define what our domain was, because then if I want to feed an input into it, I have to make sure that it's within that domain. Yes, good question. Let's do another one like this. We did a difference and a product. Why don't we try all of them? We're going to do a sum, a difference, a product, and a quotient. Before I get started, are there any restrictions on the domains of f or g? No. So my domain for the sum, the difference, and the product would be all real numbers. For the quotient, it's not going to be all real numbers because g of x can't equal 0, which means x can't be equal to 0. Are they asking me to put 0 in the place of x? Then that won't be a problem. 3 is within the domain for the sum, the difference, the product, and the quotient. All right, so let's find our sum first. So I have x plus 3 plus x squared. Pretty much fully simplified, right? So what do I do from here now? Yep, we're going to sub 3 in the place of x. You could put it in order, but I'm going to evaluate this now for 3. So I'm going to get 6 plus 9, and 6 plus 9 gives me 15. So the sum of f plus g of 3 is 15. And then the difference, f minus g of x. So I have x plus 3 minus x squared. No simplifying that I have to do before I substitute 3 in. So I'm going to substitute 3 in the place of x. So I have 3 plus 3 minus 3 squared. So 6 minus 9, which is going to simplify to be negative 3. Product. F times g of x. So x plus 3 times x squared. I'm going to distribute that. So x cubed plus 3x squared. Then I'm going to substitute 3 in the place of x. So I have 3 cubed plus 3 times 3 squared. So 27 plus 3 times 9, or 27 plus 27, which gives me 54, absolutely correct. And then we have our quotient, f over g of x. So I would have x plus 3 over x squared. Can't simplify that any further, so I'm going to substitute my 3's in the places of all the x's. So up in the numerator, I would have 3 plus 3. And down in the denominator, I have 3 squared. So 6 over 9. Will that reduce at all? Reduces down to 2/3. So f of g of 3 is equal to 2/3. Do you guys have any questions about this part? I had a really good question in first period where somebody pointed out, they said, well, if we just evaluated f for 3 and g for 3, then I can do the operations with that. My short answer to that is yes, and my slightly longer answer to that is yes, but be careful, because you could run into some domain issues. It is better to find your sum or your difference, your product or your quotient, and then substitute in. Most of the time you're going to be okay to do it the other way around, but be very careful if you're going to do it the other way. One last thing that I want to introduce, and then you guys will need to watch a video tomorrow to finish out 3.7. Function compositions. So when you see f and then a little open circle of g of x, we read this f of g of x. And it's exactly the same as other notation that you might have seen that looks like this, f of g of x. These are interchangeable notations. It really just depends on the book or the professor's preference. Absolutely interchangeable notations here. If g comes first, then we read it g of f of x. When we do function compositions, we're going to take the first function. So on the one that I just did in red, the first function would be g. That is my outside function. And the input that we're going to put in the place of the x is the entire function that is named second. This one is f of x. This one's a little bit strange. You have a function, and you feed itself back into it as input. It does not mean anything different, no. G of x, you have your function g. You feed itself back into it as input. Applications for this, it feels very confusing when we write it like this, but there's a lot of computer programs when you write functions where you'll say, okay, I'm going to take the input that I'm going to use for this function is this function itself. And I'm going to feed it back into itself over and over and over. So it's going to repeat these processes. I want to practice just a little bit with these compositions, and then the video tomorrow will do a lot more with compositions of functions and talking about domain. You guys okay if I put our examples up? Okay. You good? All right. So we're going to do all 4 of these. Let's do f of g of x first. So fog and goff. So I have f of g of x. When I'm doing these on my own, I often really like to use colors to keep me from getting confused. So f of x is my outside function. So I'm going to recopy my function f of x, but I'm going to leave some space because we're going to do a substitution here. And in the space where x goes, that's where I put my second function, g of x. And then I'm going to simplify it. That would be negative 2x squared minus 1. Going the other direction with this, with g as my outside function. So it'd be g of f of x My function g is negative x squared, so it's negative something squared. And that something is going to be my entire function f. What is our function f? 2x minus 1. Order of operations says the first thing I need to do to this now is square it. So that would be 4x squared minus 4x plus 1. And then I distribute a negative 1 to each piece. F of x. Hold on. So I have my function f of x on the outside, not 2x, 2, and then we make our substitution, minus 1. And I'm going to put f of x inside itself. So then I would distribute my 2. So I get 4x minus 2 minus 1. So 4x minus 3. Very similar with g of x. I have my function g of x on the outside. And then we're going to feed g of x into itself. So negative something squared. And I'm going to put g of x in here. So if I take negative x squared and I square it, I'm going to have negative and then x to the 4th, so this would just be negative x to the 4th. So there's a little bit of practice with compositions. Like I said, the video tomorrow we'll do quite a bit more with compositions of functions. You guys do need to watch that because that will finish out 3.7. Your 3.7 homework is due tomorrow. Sorry, not tomorrow. 3.7 homework is due on Friday. My apologies. Friday will be our in-class review day for your test. Test is on Monday. Please make sure that you are working through that review. If you don't have a copy of the review, please see me. 7, I think that's it. Okay. I will also make sure that the answers are posted tomorrow. My work will be posted on Friday, but the answers to the review itself will be posted tomorrow. Have a great rest of your day, guys. I'll see you later.